Okay, I just turned on the recording. So first, let's do a quick mic check. Can you guys hear me okay? Give me thumbs up or thumbs down or chats. Okay, good. Glad to hear that. All right. Okay, so as I said last time, I am not going to be introducing any new material today. Just going to be answering any questions that you guys might have about the midterm exam. So I looked online just a few minutes ago, and I didn't see anybody had submitted your CAD creations, which is okay. It's not due till Friday. Um, let me just throw it out. Do any of you have any questions? Did you guys give it a try and run into any problems? So tell you what, you can either type your responses into the chat window, or if you want, you can turn on your mic and speak your questions. If you hold down the space bar and keep holding it down, your mic will come on for as long as you're holding it down. As soon as you release it, then you'll be muted again. So does anybody have any questions? Okay, so Riker does. Okay, good. And if you don't, I have a couple things that I was going to talk about anyway. But okay, Riker, go ahead. You wanna speak it into your microphone, or do you want to type it? If you're talking, I'm not hearing you. You're typing, okay. You don't have a microphone? Here's a case where it might be easier to use the microphone. But if you don't have one, then okay. Okay, while Riker's typing, how about any of the rest of you?
At least. Okay, does it work?
Oh, okay, good. Now I can hear you, Riker.
Okay, it does. So when we did the finish the gear box part, on your diagram it had like a crank and another thing at
I
the
called
end.
it, yeah, I called it an output flag.
Yes. So do we have to put that on there as well?
Yeah, I would like that.
Okay.
Let's see, let me skip through these. Okay, so what you see here is a copy of what is on Canvas. I trust you guys have already looked at it. Okay, so you see the files are right there. Okay, all right, so yeah, this output, or the crank here, I definitely do want that included, because when you calculate the gear ratio, I need to know which shaft is the input shaft and which one is the output shaft, because the gear ratio is going to be very different depending on which one it is. In fact, tell you what, let's just jump ahead to that. Okay, all right. So like in this example right here, the shaft on the left is the drive shaft, and so the one on in the middle here is the one that's being driven. Okay, so if this guy's got 40 teeth and that guy's got 8 teeth, that means the multiplication factor here is going to be 5, because 40 divided by 8 is 5. So that means every one time that the big guy spins, the small guy is going to spin 5 times. If you had reversed that, if this guy right here was the drive shaft and this guy right here was the output shaft, your gear ratio would not be 5. Your gear ratio would be 1/5. Okay, because if this is where you put the crank, okay, so every time you turn the crank one time, the output shaft would only turn 1/5. Okay, so it makes a big difference. So yes, I do need to know which one's your drive shaft, which one's your output shaft, and the best way to show that is by putting a handle on the shaft, the drive shaft. Okay, so Sky is asking if you could you use more than 4 gears? Yeah, I'll allow that. That would be kind of interesting, in fact, to see what you guys come up with. So you have to have at least 4. But if you want to do more, yeah, I will allow that. Okay, any other questions? Okay, so tell you what, I'm going to just briefly go over a couple of things that other people might want to know. So the people who aren't on, who are not online right now, they might possibly want to know this. So let me go back up here. Let's start with the questions on the quiz, which, by the way, one of you did not get a perfect score on this quiz, and I don't know how you could possibly miss these. I mean, these questions are intended to be super easy, and all of you except for one, you got a perfect score, but one of you did not. Oh, and by the way, 2 students did not take the quiz. Oh, we got to do something about that. Okay, so all right, so what is due on Wednesday? Well, nothing. The assignment's due on Friday, but I definitely wanted everybody to have tried it by today. Okay. Okay, so for the midterm exam, how many STLs files do you need to submit? Okay, 2 of them. And make sure, I want everybody to understand this because it's really important. One of the STL files should show the entire gear train. So this is the real, real type thing here. Okay, so one of your STL files needs to show the entire gear train so I can see how everything fits together, which one's your input, which one's your output, and including the support material. But the second STL file, that should only be the support, okay, not the gears. Because, and my reasoning there is that's what you're going to send off to the machine shop to have made, because you're going to buy the gears, right? So you're not going to have a machine shop buy the gears for you, or you're not going to have a machine shop make the gears for you. You're going to buy them, right? So the thing that you're going to send out to the machine shop, or if you're going to 3D print it, the thing that you're going to 3D print would be the support. And so I need to have a separate STL file just for the support. But I also need an STL file that shows how they all fit together. Okay. All right. So if you didn't understand quite how to do everything, then I hope you at least tried it. I hope you also didn't panic. Okay. So for all of these last questions, the answer was, well, spend a reasonable amount of time trying to figure it out. But if you can't get it, don't panic, because we are going to meet on Wednesday. And so right now, so here we are meeting. Okay. All right. So let's take a look at this. So your CAD file here, actually tell you what, let me switch my sharing here. I'm going to, instead of sharing the PowerPoint here, I'm going to share the actual, let's see where to go. Okay, here we go. Okay. All right. So what you guys are seeing right now is the teacher screen in Canvas. So these buttons that you see right here, you guys wouldn't have those. That's only what a teacher would have in the grader thing here. Okay, so here on Canvas, I think I've described pretty thoroughly what's needed. So here's a couple of views of the completed assembly. So you can see from various angles what I want it to look like. And yes, I do want a handle, which you have to create from scratch, but that should be really trivial. And then I also want the output. Now I call it an output flag because it makes it easier. Okay, so right here with the real thing here. Okay, if I didn't have this little piece right here, it wouldn't be obvious to me how much is turning. So watch the crank and watch the output shaft. So I turned the crank once, the output shaft only turned a tiny little bit. I have to do it twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. I have to turn this guy 9 times before this guy turns once. And if I didn't have the output flag on there, then it wouldn't be clear that was happening. So the output flag is actually important. Okay, so over here I have instructions on what to do. Okay, here I have, I've labeled everything. So notice I've got 3 shafts, and I want yours to have at least 3 shafts. But Sky, if you'd like to do a few more than 3, hey, more power to you. And in fact, tell you what, I will give a little bit of extra credit, not a lot, but I will give a little bit of extra credit if you do more than 4 gears. And so you'd need more than 3 shafts in order to do that. Yeah, no, I won't give a lot of extra credit, but I will give a little bit, and some of you do need extra credit. Okay, so I need at least 3 shafts, a drive handle, an output flag. Okay, I do want you to use the couplers. Okay, so the coupler that I gave you the STL file for, okay, that coupler is a big tall coupler. Um, so I want you to take the tall coupler and I want you to shorten it down. The rest of them, the gears and the shafts, you don't want to change the size on those. Well, the shafts, if you want to make the shaft longer, that would be okay. But for sure, don't change the size of the gears. That will mess everything up. But the coupler, feel free to go ahead and shorten that up if you want. And so when I put it on here, I'm not actually using it as a coupler, because remember what we talked about with a coupler? A coupler is if you have two shafts and you want to stick them together. That's not actually what I'm using this for. The reason I'm putting the coupler on here is just so that the thing doesn't slide around, because you may remember, okay, so here's my real thing. This thing here is what I'm calling the coupler. If that thing wasn't there, when I crank, you see what might happen here? It slides around like that, causing problems. So here I crank and nothing happens. So I need something to keep it from sliding around. And so what I've done is I've taken a coupler, and a really short one, and I put it there. So it's not really acting as a coupler. It's really acting as something to hold the shaft in place, right? So if you need a long shaft, I want you to put that there so it doesn't slide around. And I hope you can understand why we need a long shaft, because see how the output flag here, if this shaft wasn't long enough, this output flag, when we could try to turn it, it would hit the gear. Let's see, okay, here maybe it's a little bit more clear in this little slightly enlarged one. If this green shaft was too close to my red support plate, when I try to crank the shaft, it's going to hit the gear. And so I need the shaft to be long, and I need the coupler so it doesn't slide around. Okay, and then like I said a few minutes ago, in addition to giving me an STL file for the entire assembly showing me how everything fits together, I also want an STL file just for the support piece by itself, because that's the thing that you would send off to the machine shop, or that's the thing that you would send to your 3D printer. And you have to have a separate STL file just for that. Okay, now I do have a couple other things that I could talk about that I think people might want to hear. But before I do that, let me just pause for a sec. Any more questions from anybody? Now, there is one thing that I did last time where I used the ruler to help figure out where the holes should go. And after the class was over, it occurred to me that, there's a way easier method there. And so I'm going to show you that easier method. But before I do that, let's see. So Danny is asking, can the gears be arranged? Not only can they be arranged, but they have to. You see what it says right here? It says, do not copy my gear arrangement. Okay, I do not want you to give me an exact copy of what I did. I want you to rearrange the gears. Okay. So let's see. So you're saying have the 25 tooth with another one? Yeah. Yeah, absolutely. Do not copy my gear arrangement. Come up with your own. Okay, so unless anybody has any more questions, let me talk about that one thing where last time I tried to use the ruler and it was a little awkward, and then afterwards I said, there's a way easier way. Okay, so let me go back in here to my share thingy. If it'll let me, come on. Okay, I've got too many windows popping up here, making it difficult. Okay, here we go. And let's see, where'd it go? Okay. Did I? Okay. Oh, I see. Okay, I see what the problem is. Okay. All right. So now, are you guys seeing the Tinkercad now? Okay. Okay. Good. All right. Okay. So let's say that I've got a problem, which I've purposely done something here that has a problem. So you see my support structure. I've got two holes. One of them has the shaft in it, and that's got the gear on it. And so I've gone ahead and created another hole, and I purposely put this hole in the wrong place. And I hope you guys can see what the problem is. Okay, if you look through the hole, you can see the gear there. Okay, so if I come over from the other side here, okay, you see I won't be able to put another shaft in that hole there because my gear there, here's you can see clearly here, right? This hole is too close to the first hole. I can't fit a shaft in there because it's going to hit the gear. All right. So what I need to do is I need to figure out how far apart should those holes be. All right. Well, the first thing that I need to do is I need to figure out which gears am I going to use. Okay. So let's come over here. I'm going to center it on that guy. Okay, so let's say that this is one of the gears that I want to use. And let's say I want to use the big gear as my other gear. So let me import that other big gear there. Okay, so I'm going to come over to import, choose a file. Here's the folder where I put the parts in. So I'm going to take the big gear, the 40 tooth gear, and I'm going to import that one. Okay, it's thinking about it for a second. There it is. There's the big gear. Okay, so now let's say that the two gears that I want to use are these two. All right, so I need to position them next to each other like that. And then I want to zoom in to make sure that the teeth are fitting properly. So, okay. So you can see that they're not as quite where I want them to be. So let's, okay, there, okay, that looks good. Okay, the teeth are fitting properly. Okay, so what I want to know then is I want to know how far apart should I make the holes so that the shafts will be right. So last time what I did was I used the ruler and it was really awkward. And then afterwards I said, well, duh, there's a much easier way. So here's the easier way. What I'm going to do is I'm going to grab this square here. I'm going to pull the square in. I'm going to position it so the left edge of the square is right in the middle of the shaft on the left gear. So if I zoom in there, you see, okay, so the left edge of the square is right where I want that axle to be, okay? But the right edge is not. So what I'll do is I'll just drag this and I'll pull it over there until it is. Okay, and let me change my positioning. Let me zoom in a bit there. Okay, looks like it didn't quite come far enough, so I'm going to do a little bit more. Okay, so I'm thinking, okay, that looks good. All right, so now if I want to know how far that is, what I can do is I can just zoom back out a bit and look right there. It tells me exactly how far it is right there. So I can use this square as a ruler. And it turns out it's a lot easier to use than the built-in ruler. Okay, so I want those holes to be 33 centimeters apart, or 33 millimeters apart, okay? So then what I can do now is I can come back over to here. And so then I can take that hole right there. And now I'm going to have to ungroup it here. Okay, so I've ungrouped it. So now I'm just going to take the hole and then slide the hole over there. And then I can take my block here and I can bring him over and use him as a guide. Oops, come back here. Okay, I need to lift him up there. Okay, so you guys see how this works, right? So I can just bring him right in there and use him as a guide so I get this hole positioned exactly where I want it to be. And let me zoom in. If you're zoomed out, it's hard to grab it and move it. Okay, so I can put this guy exactly where I want him to be. Okay, and now I get the big square out of the way. Whoops. Okay, get him out of here. Okay, and then now make sure that these holes are lined up. So I'm going to click the one hole, I'm going to hold the shift key, click the other hole, and then I want to align these guys, okay, I want, let's see, why is that not working? Let me zoom in a bit here. Okay, click him, click Align, okay, and then click middle, or if they're the same size. Okay, so now I know that they're exactly even with each other, and now I know they're the right distance apart. So now what I can do is click here, click here, click here, group them back together again, and voila, life is good. So I got my hole where I want them to be. Okay. Looks like I messed up on my hole there. Let me ungroup this. I must have changed the shape of the hole when I was dragging on it. I need to push him back in there. Okay. All right. So anyway, so now we should be good. All right. So how about gear ratios? Does anybody have any questions about gear ratios? Do you understand how that's supposed to go? Could you calculate the gear ratio? Okay, so does the no mean no, you don't have any questions? Oh, you're still a bit confused. Okay. All right, so let's go back here. Let's talk about gear ratios. Let me go back to my PowerPoint slide. Okay. Okay, or not. Hang on a second here. Was that not the PowerPoint slide? Why does it not want to? Why is my screen locked up here? Okay, hang on a sec while I try and figure out why I'm not getting what I think I should be getting. Okay. All righty, let's try this now. Okay. All right, so let's talk about gear ratios. All right, so what you're looking at right here is the one we talked about a minute ago. If I just look at these two gears right here, forget the guy over on the right, just look at these two. Okay, so if this big gear has 40 teeth and this small gear has 8 teeth, so then that means that when the big guy goes around one time, 40 teeth are going to pass by this point right here. And every time a tooth passes this point right here, it causes one of the other teeth on the small gear to go. Okay, so if 40 teeth pass by here for one full revolution here, that means this guy, 40 teeth has to go by for him. So that means that he is going to spin 5 times. So if you only look at these two gears, the gear ratio would be 5. So that means when my big guy turns one time, my small guy turns 5 times, right? So I hope that's straightforward. But this is only one piece of the bigger part. So we need to worry about these guys on the back. So let me go to, I'm going to come around to the back side now. Okay. All right. So, okay. So now we're looking at the back side. So these are the two gears there. So again, we have to figure out now what's the gear ratio for these guys by themselves, and then we'll combine it with the other guy later. All right. So you look at how many teeth they have. So the big guy, this is the one that's doing the driving now, because this was the real drive shaft, but the real drive shaft drove the intermediate one. And so now the intermediate one is going to drive the third one. Okay, so this guy is doing the driving of that one. So he has 25 teeth. This guy only has 16 teeth. Okay, so if we take the ratio of those, if we divide them, then we get a ratio of 1.6. So it means every time this guy goes around once, the smaller guy will go around 1.6 times. Okay, so then we would say that the multiplication factor just for these guys by themselves is 1.6. Okay, but then we have to say, well, wait a minute, they aren't by themselves. These two guys, so this is my drive shaft. So the first pair of gears is connected to the second pair, so they're going to drive, so what we have is a compound gear train. So what I have to do then is I have to multiply the multiplication factor for the first guy multiplied by the multiplication factor for the second guy. So 5 times 1.6, so 8. So what that means is if I turn my crank handle, if I turn it one time, my output shaft here is going to go 8 times. So my multiplication factor for my gears here is 8. Now, what if I switch that around? What if instead of making this be the drive handle, what if I have this be the output shaft? Okay. So what I've tried to show here is, you see how I have a little handle here that I didn't have before. Now I didn't take the handle off of here. I was lazy. I left it on here. But this thing that used to be the drive shaft, now it's the output shaft. Okay. So now what's going to happen is the small gear is driving the big gear. And so the multiplication factor is not going to be 1.6 anymore. It's going to be 1 divided by that. Okay. And then over here, so after this guy gets driven by the one on the left. And so now my little gear is going to drive my really big gear. So the multiplication factor here is not going to be 5 anymore. It's going to be 1/5, because this guy, every one time he goes around, this guy only goes around 1/5 of the time. Okay, so the multiplication factor then is no longer 8. The multiplication factor is now 1/8. So that what that means is, every time that my input handle, my drive handle, my crank here, every time it goes around once, my output handle is only going to go around 1/8 of a turn. So instead of gearing up, now I'm gearing down. And next week we're going to talk about that. We're going to talk about machines and gear trains like this. We're going to talk about, when do you want to gear up? When do you want to gear down? What are other ways of doing this? This is just one machine. There are many other types of machines. We're going to talk about that next week. But let's not worry about it for right now. Okay. So those are all the points that I anticipated people might have questions on. Does anybody else have a question? Not seeing anything. Okay, then. All right, so let's talk about what's going to happen on Friday. Okay, so before Friday at 11, so by 10:59 on Friday, you need to submit to me your files. And so let's go back up here again. Oh, not up here. Let's go down. Okay, hang on a sec. Okay. All right. So remember, in addition to the STL file for the entire assembly, I also need a separate STL file just for the support. So you need to send me both of those STL files, and you need to calculate the ratio, the gear ratio. Okay. So you need to submit that by Friday at 11 o'clock. Now, on Friday, I do not plan to introduce any new material. All I'm going to do on Friday is I'm going to come online in case anybody has any questions. If nobody has any questions, I'm going to say, okay, guys, and basically no real class on Friday. I'm just going to come on to see if you have any questions. And I'm not going to give you any homework on Friday, and I'm not even going to have a quiz on Friday. So Danny is saying, really? Yep, really. Okay, I mean, when you guys take a major test like that, I think you deserve a little bit of time off. So yes, I agree. Yay. All right, so Riker, you're asking if we can talk together after class. Yes, I'll stay on after class. And if you really want it to be private, we can, what I can do is I can lock the meeting after everybody else leaves. I can lock it so that nobody else can listen in. Okay, so any other questions? Going once, going twice. Oh, okay, we have a question. All right, so Sky wants to know, when we submit the gear ratios, should you give the ratios between all the axles? That would be good, but it's not what I require. All I need to know is, what is the total ratio of all three of the axles put together. But it is a good idea to do what you're suggesting there, Sky, because that way I can see whether or not you just made a silly mistake. If you show me that you calculated the gear ratio for the first two axles and you did that properly, and then you calculated the gear ratio for the second two axles and you did that properly, but when you combined them together, you made a silly mistake, like let's say, let's say you calculate the gear ratio for the first one and the gear ratio for the second one. And then instead of multiplying those two numbers like you're supposed to, what you do is you just add the numbers instead. That's a common mistake that people sometimes make. But if I can see that you did that and you did most of it right, and it was just that little thing that you got wrong, I can give you partial credit. Whereas if you don't do that, if you don't show me how you got your answers, if all you do is you tell me what your final answer is, and your final answer would be wrong if you made that mistake, and I don't know whether it was a major misunderstanding or whether it's just a minor misunderstanding. So yes, I definitely always recommend show your work, and because that way I can be more generous with partial credit if I need to. Okay, so again, going once, going twice, sold. Okay, so what I'm going to do then is I'm going to stop the recording.